Have you ever wondered how a live stream from halfway across the world feels like it's happening right in your room? Or how these massive websites with literally millions of people on them at once can load in the blink of an eye? Well, it's not magic. It's an incredible piece of technology working silently behind the scenes. And today, we're going to pull back the curtain on this invisible backbone of the internet. So let's just dive right in. On the left here, you see the internet's original big problem. One single server trying to handle the entire world. I mean, imagine everyone in the country trying to get coffee from the exact same shop. It would be a total mess, right? Slow, frustrating. Yeah. The solution on the right is just so elegant. CDN distribution. Instead of one shop, you have a franchise on every corner. It's closer to you, it's faster, it's just better. And that's really the core idea we're going to unpack. All right, so here's our game plan. First, we're going to dig into the problem itself, what we're calling the internet's bottleneck. Then we'll shift gears and start thinking at scale, like an engineer would. After that, we'll officially meet the CDN. Then we'll look at how CDNs really work under the hood. And finally, we'll wrap up by understanding why it's truly the web's invisible backbone. Okay, let's kick things off with section 1, the internet's bottleneck. And it all boils down to one simple question. In a world where everything feels instantaneous, why does physical distance still matter so much when we're online? You know, as the internet started to explode back in the late 90s, that whole one server model it couldn't keep up. Every single request from every user, no matter where they were in the world, had to travel all the way to that one server and then all the way back. This created what we call a massive performance bottleneck. The result? You guessed it. Painfully slow loading times, websites that would just crash under the load. It was a frustrating experience. The system just was not built to scale for the whole planet. So how on earth do you solve a problem that big? Well, it takes a totally different way of thinking. You have to start thinking at scale, and that means adopting a very specific engineering mindset. This right here is probably the #1 rule in designing any large-scale system. Everything is a trade-off. There is no single perfect solution. For example, do you want the absolute fastest speed possible, even if it costs a fortune? Or is a slightly slower but way cheaper solution better? Do you need every user on Earth to get the exact same version of a file at the exact same millisecond? Or can you live with a tiny delay if it makes the whole network more stable? See, engineering at scale is all about the art of making the right compromises. Now, to really get these trade-offs, we need to know 2 key terms. The first is latency. Just think of this as pure delay. It's the time it takes for one little packet of data to get from point A to point B. It's that annoying pause you feel after you click a link, before anything even starts to happen. High latency is basically the arch nemesis of a fast internet. And the second term is throughput. So if latency is the travel time, throughput is the size of the road. It's how much data you can actually cram through that connection at once. You could have a super fast car that's low latency, but if you're stuck on a tiny one-lane road, your throughput is just awful. The real goal for any scalable system is to get the most throughput you can while keeping that latency as low as possible. And all of this leads us to the big one, scalability. A system that's truly scalable is one that gets faster and can handle more traffic when you add more resources to it. It's what separates a system that's fast for one person from a system that stays lightning fast for millions of people all using it at the same time. All right, with those key ideas locked in, it's time to finally meet the hero of our story, the Content Delivery Network, or CDN for short. At its heart, a CDN is all about geography. It's basically a smart network of servers. Think of them as local copies of the main server that are spread all over the planet. So instead of your computer having to ask for a video from a server in, say, California, the CDN lets you grab a copy from a server that might be just down the road. I mean, this simple idea, it changes absolutely everything. And the benefits are immediate and they are powerful. By closing that physical distance, CDNs just demolish page load times. That's a direct shot at latency. They also make content more available. If one server has a problem, another one can just pick up the slack instantly. And for the companies running the websites, it actually lowers their bandwidth costs because their main server isn't having to do all of the heavy lifting. It's a win-win-win. So that's the what and the why. But now, let's get into the how. How do these things actually work? It's time to look under the hood. The real magic is in these things called points of presence, or POPs, POPS for short. You'll also hear them called edge servers. These are the individual data centers that make up the CDN's global network, and they're placed really strategically at the edge of the internet, as close as they can possibly get to big cities and to you. Now, there are two main ways the content actually gets onto these edge servers. On the left, you have a push CDN. In this case, the website owner actively pushes their files out to the CDN storage ahead of time. Think of like a huge video game update or a new movie on a streaming service. Big files that you know people will want and that don't change. Then on the right, you have a pull CDN, which is a lot more dynamic. Here, when the very first user in a region asks for a file, the local edge server automatically pulls a copy from the main server and saves it. This is perfect for something like a news website or social media, where the content is always changing. So let's trace what happens when you click on something. Step 1, you request a website. Easy enough. Step 2, the Internet's address book, which is called the DNS, does something really clever. It sends your request not to the website's original server, but to the closest CDN edge server. Step 3, if that server has a copy of what you want, we call that a cache hit, it sends it to you instantly. Boom, done. And step 4, if it doesn't have it, that's a cache miss, no big deal. The edge server just quickly grabs it from the main server, saves a copy for the next person who asks, and then sends it right along to you. It's just a beautiful, efficient system. And this is why all of that matters. Just look at these numbers. It's kind of mind-blowing. Getting data from your computer's fastest memory takes half a nanosecond. Sending a single packet of data across the Atlantic Ocean and back can take 150 million nanoseconds. The laws of physics are the ultimate speed limit here. By moving content from that cross-ocean trip to a local data center, a CDN just wipes out almost all of that travel time. This is the real physical reason the internet feels so fast. And this brings us to our final section, the web's invisible backbone. Because this tech isn't just some abstract idea for engineers. It's something that directly shapes your online life every single day. So where do you actually run into this stuff? The short answer? Everywhere. That Netflix show you're binging? Yep, CDN. That thing you just bought on Amazon? CDN. That massive new update for your favorite game? You guessed it, CDN. The endless stream of photos and videos on your social media feed? All of it is being delivered to you quickly and reliably by a CDN working totally silently in the background. And just how common is this? Well, it's estimated that a huge portion of all internet traffic, we're talking over 70%, is served through CDNs. It's not an add-on anymore. It has fundamentally become the standard way to deliver a fast, reliable web experience to a global audience. It really is the backbone of our digital world. So CDNs solved this enormous scaling problem by decentralizing the delivery of content. And that leaves us with a really fascinating question for the future. In a world of peer-to-peer networks, where the content itself is also being created and shared by everyone everywhere, what does the next version of this invisible backbone even look like? That's definitely something to think about. Thanks for